So for the part 2, we were told to make a reduced binary decision diagram, and in part 1 we find an OBDD. So from that we can like work our way through it and be able to reduce it into a simplified diagram. So the first step of this is like we should see the fact that the outputs are basically the same if you chop it up right here. So you can see like whichever way A goes, this output should be the same as this output. So when we reduce it, this part should be the same as this part right here. Um, and it's also, so then we start from the bottom generation. So like this child branch right here. So we know that this guy, this C right here, it can go to take a path of 0 and get an output of 0, or it can take a path of 1 and get an output of 0. So no matter which way it takes, it will output a 0. The same case here because it's identical. C can go to 0, C goes to 0, and so your output should be 0. So we can replace this C right here as a 0, because no matter which way, because when B takes a path of 0, your output is basically going to be 0, because no matter which part of C you take, it's going to be 0. But then if we look on this branch right here, C can take a path of 0 and go to 0, and C can take a path of 1 and get a 1. So you can't really reduce this part right here. So we retain this part, as you can see, on the one branch of B. But then we go up a generation, so then we go to like the parent part, and we can see that in this parent part right here, like if A takes a path of 0, this parent part is basically going to have the same children. If A takes a path of 1, this parent part is still going to have the same children. So you can see that if B goes up here, this is basically our output because they're both identical, as I mentioned before. So we can reduce it even more and say, if B takes a path of 0, it goes to 0, right? If B takes a path of 1, it can decide between two paths of C. But this A doesn't matter anymore because A can take 0 or 1 and still end up with the same result. And then just simplifying a bit more, we can make this diagram a bit cleaner by saying this 0 path here is basically going to the output of 0. So you can see here that we have 0 and a 1, and then B goes to 0, 1, and then if B is 1, C can take two paths, and it ends up with 0 and 1.